Tonight, we journey beyond the edge of everything you've ever known. Beyond the sun that warmed your childhood afternoons. Beyond the stars you've perhaps wondered about while lying awake in the dark. We drift into a place where time itself begins to lose meaning, where distances become almost poetic in their impossibility, and where a single object, a human-made spacecraft no larger than a car, has become humanity's most ambitious messenger into the void. Imagine for a moment that you are sitting in the darkest place you've ever been. Perhaps it's a field far from city lights, or a memory of such a place. The night sky stretches above you, infinite and patient. Now imagine that somewhere up there, at this very moment, there is something we built. Something we sent into darkness half a century ago, and it is still traveling, still moving forward, still sending whispers back to us across the incomprehensible distances of space. This is the story of Voyager 1 and the unimaginably long journey that stretches before it. A journey that will continue, with almost certainty, for 10 trillion years. But before we drift any further into this vast expanse, if you find comfort in journeys like this, if there's something about the universe that makes you feel both infinitely small and strangely connected to everything, you can gently support this channel by liking this video. Subscribe, if you haven't already, to return here whenever you need to remember what it feels like to be part of something so much larger than yourself. And perhaps, if you feel moved, share in the comments where you're listening from, somewhere out there in the world. Perhaps under stars just like the ones Voyager sees, but from the other direction. Now let us begin. In 1977, during a window of time that would never come again for nearly 2 centuries, 2 spacecraft were launched into the darkness. They were born from human curiosity, human determination, and a particular kind of audacity that belongs to the species that wonders. Voyager 1 and Voyager 2, named simply and humbly, were designed to explore the outer planets, Jupiter, Saturn, and beyond. Their mission, initially, was short by the standards we're about to discuss. A few years, perhaps a decade. Just long enough to take pictures, to gather data, to send it home, and then to fall silent into the void. But something extraordinary happened. The engineers and scientists who built these machines built them better than perhaps anyone truly expected. They built them with such care, such precision, such a kind of love, that Voyager 1 simply refused to stop working, refused to fall silent, refused to accept that its journey should end. And so it has continued, beyond the planets, beyond the sun's gravitational pull, beyond what we might call the known universe, in the sense that Voyager is the farthest human-made object from Earth that we can still touch, still communicate with, still hear from across the darkness. Now, at this moment in our timeline, May of the year 2026, Voyager 1 is more than 14.4 billion miles from Earth. That is almost 100 times the distance from the Earth to the Sun. If you were to travel at the speed of light, the fastest thing that exists, it would take you 20 hours to reach it. If you were to travel in the fastest aircraft humanity has ever built, it would take you more than 2 million years. The spacecraft is so far away that the radio signals it sends back to us, traveling at light speed, take more than 20 hours to reach Earth. When we receive a message from Voyager, we are hearing from the past. We are listening to a whisper that began its journey before our today had even arrived. And yet, this is only the beginning of our story. Because Voyager 1's true journey, the vast odyssey that has barely started, will continue long after humanity itself has changed beyond recognition, long after our sun has transformed into a red giant and swallowed the inner planets, long after the solar system itself has been scattered by the gravity of passing stars, long after the very concept of Earth has become nothing but a particle of cosmic dust, if even that remains. This is where the universe becomes truly mysterious, not in the terror of it, but in the vast, slow, almost meditative grandeur of deep time and deep space. Voyager 1 is traveling at approximately 37,000 miles per hour. That sounds impossibly fast when we speak of it relative to Earth, faster than any human has ever traveled, faster than any human has ever lived to imagine moving. And yet, in the context of the universe, this speed is almost gentle. It is a slow waltz across the cosmos. And so, to truly understand the journey of Voyager 1, we must begin to expand our sense of time itself. When we talk about distances in space, we measure in miles, in kilometers, sometimes in what we call light years, the distance that light travels in a single year. But when we talk about the future of Voyager 1, about the 10 trillion years ahead, we must learn to think in scales that our brains are almost not designed to hold. And yet, you can hold it. Your mind is capable of this. All you need to do is relax and let the numbers flow like a gentle current. Slowly, something begins to change in our understanding. The spacecraft that seems so far away, so impossibly distant, is actually moving through time at a pace that is almost stationary when measured against cosmic timescales. And this is where we discover something profound. Voyager 1 is not moving through space and time the way we usually think about such things. It is moving through a place where time itself has a different meaning. The Milky Way galaxy, our home, is a vast spiral of stars and dust and dark matter, spinning slowly in the darkness. It is about 100,000 light years across, which is to say, if light were to travel from one edge to the other, it would take 100,000 years. Inside this galaxy are something like 200 billion stars, each one a sun, each one perhaps surrounded by planets, each one potentially harboring life, or the echoes of life, or the possibility of life. Voyager is currently traveling through what we call the solar neighborhood, the region around our sun. But if it were to travel, at its current speed, to the nearest star after the sun, it would take roughly 75,000 years. Now imagine, for a moment, that you are Voyager. Imagine that your consciousness is contained within this small, cold spacecraft, and you are aware of your own motion. You are traveling toward a star so distant that the time required to reach it is longer than all of recorded human history, longer than the rise and fall of empires, longer than the evolution of human language and culture and consciousness itself. And when you arrive at that star, if you were to somehow arrive, you would be no more advanced in your journey through the galaxy than a single footstep is in a 1,000-mile walk. And yet, Voyager will continue. It will continue long after that. To understand what will happen to Voyager 1 over the next 10 trillion years, we must first understand what we mean by time on such a scale. We must learn to think about the universe not as it appears to us moment by moment, but as it unfolds across eons so vast that they are almost impossible to visualize. Let us establish some reference points. 10 million years is longer than human civilization has existed. It is a span of time so great that the continents themselves move noticeably during such an interval. The Rocky Mountains, those ancient and majestic peaks, will be worn down significantly in 10 million years. The coastlines of the continents will shift. Species that are alive today will, with almost certain probability, be extinct. The shape of life on Earth, if Earth still exists, will be unrecognizably different. 100 million years takes us back to the time of the dinosaurs. It is a span of time so great that it begins to reorganize the very face of the planet. 1 billion years is 1,000 times longer than human civilization. It is a span so vast that we can barely comprehend it even with our most ambitious words. Yet 1 billion years is only 0.007% of the 10 trillion year time frame we are discussing. The 10 trillion years stretches ahead like an ocean, and 1 billion years is a single drop of water within it. Now, imagine this. If you were to count out loud once per second, it would take you more than 300 million years just to count to 10 trillion. If you were to take 1 step per second, walking forward continuously without rest, it would take you the same 10 trillion years to travel the distance in numbers alone that 10 trillion years represents. And here is where our meditation on time becomes almost beautiful. Voyager 1 does not experience time the way we do. From the perspective of physics, from the perspective of relativity, Voyager 1 is moving so slowly through space that, relatively speaking, it is almost still. And the universe, meanwhile, continues its vast and ancient dance around it. The stars that Voyager is currently heading toward, in what we call the Oort cloud, a theoretical shell of icy bodies at the edge of the sun's gravity, are so distant that Voyager will not reach them for thousands of years. But beyond that, beyond the reach of the sun, beyond the gravitational boundaries of our stellar system, Voyager will drift. It will drift into the darkness between stars. It will drift for longer than stars themselves have existed. Let us now consider what will happen to the sun during this time. Our sun, that golden disk that has warmed the earth for 4.5 billion years, is currently in what we call middle age. It is stable. It is reliable, but it is not eternal. In approximately 5 billion years, a number so vast that it exceeds the entire age of the sun up to this point, the sun will begin to die. When a star like our sun dies, it does not go quietly. It swells, it grows hotter. It strips away its outer layers, creating a structure called a planetary nebula, a cloud of glowing gas that is, in its own way, a kind of funeral pyre. And in the process, it will consume the inner planets. Mercury, Venus, the Earth itself, if Earth still exists in any recognizable form by then, will be engulfed. They will be vaporized. They will become part of the substance of the sun as it transforms into something smaller, denser, colder, a white dwarf. But Voyager will still be traveling. It will be traveling into the depths of space, far from the sun by then, and it will continue to travel long after the sun has cooled to a dim cinder. And this is where something begins to become clear. The universe is not a place of dramatic endings, but of long, slow, almost imperceptible transformations. Things do not disappear quickly in deep time. They fade. They change. They become other things. And Voyager, this small messenger from a civilization that will itself be unrecognizable in a few million years, will witness these changes. Or rather, Voyager will not witness them, because it carries no consciousness, no awareness. But if we imagine standing upon Voyager, if we imagine a being of some kind riding with this spacecraft, they would see the stars slowly shift in their positions. The constellations as we know them would dissolve and reform. The Milky Way itself would appear to rotate, because Voyager would be rotating around the galactic center, pulled by the gravity of billions of stars. This brings us to another profound realization. Voyager 1 is, in a very real sense, imprisoned by gravity. It is falling. It has always been falling. Everything in the universe is falling toward everything else, attracted by gravity, by the bending of space and time itself around massive objects. The sun, a massive ball of hydrogen and helium, bends the space around it. Planets fall toward that bending, which is what we experience as orbits. Voyager, moving away from the sun, but still connected to it by gravity, is in a very real sense still falling toward the sun. It will never stop falling. Even as it drifts beyond the edge of the solar system, beyond the farthest reaches of the Oort cloud, gravity will still have a claim on it. And it is this gravity, this fundamental force that connects all things in the universe, that will determine much of Voyager 1's fate. Now, slowly, something begins to become clear. The universe that Voyager will travel through, for 10 trillion years, is not a static place. It is a living, breathing, changing cosmos. The stars are not eternal. Black holes will evaporate. The very fabric of space and time will, according to some theories, eventually break down. And Voyager will continue to travel through all of this. A small artifact of a civilization that lived for perhaps only a few million years, a blink, a breath in cosmic time. A message in a bottle sent into an ocean that is more vast than we can truly imagine. Let us now move into the future with Voyager 1, step by step, beginning with the immediate next phase of its journey. This is the phase we might call the escape, though even this word is inadequate, because Voyager is not fleeing from anything. It is simply continuing to move, propelled by the force that was given to it all those decades ago. Over the next few thousand years, Voyager 1 will complete what we might consider its final separation from the Sun. It will move beyond the Oort cloud, that theoretical shell of icy bodies and comets that represents the gravitational edge of our solar system. This region is vast. It extends perhaps a light year beyond the Sun, or even farther. By some estimates, the Oort cloud might extend nearly halfway to the nearest star. But because Voyager is moving so slowly, in cosmic terms, it will take roughly 30,000 years to traverse the Oort cloud. 30,000 years. This is longer than all of human civilization, longer than the ice ages, longer than the time since humans first discovered how to make fire. And yet, this is only a preliminary stage. As Voyager moves through the Oort cloud, it will pass near or through regions where comets are gathered. Some of these comets are ancient. Some have been here since the formation of the solar system, and it is possible, merely possible, but real nonetheless, that Voyager might collide with one of these objects. The probability is small. The distances are so vast that even in a region crowded with comets, empty space dominates. But it is not zero. If such a collision were to occur, Voyager would be damaged. Its instruments would cease functioning. Its ability to communicate with Earth would end. And it would become simply a piece of debris drifting through space, a monument to human ambition rendered silent. But let us assume, for the sake of this meditation, that Voyager continues unimpeded. Let us assume that it passes through the Oort cloud safely and emerges, eventually, into the cold darkness of interstellar space. Interstellar space, the space between stars. This is a place of profound silence and profound cold. The temperature here hovers near absolute zero, the coldest temperature that can theoretically exist. The density of matter is so low that it is almost a perfect vacuum. If you were to stand in interstellar space, unprotected, you would not feel cold in any way that human flesh could experience, because you would not survive long enough to feel anything. The lack of pressure would cause your body to undergo rapid changes. The lack of oxygen would cause unconsciousness within seconds. And yet, in this void, Voyager will travel. Imagine drifting through this space. Imagine the silence that is more absolute than any silence on Earth. No wind, because there is no air. No sound, because sound requires a medium to travel through. Just the slow passage through darkness, at 37,000 miles per hour, which is the speed of motion, but which feels, from any perspective within this void, like no motion at all. The stars around you would change, but only infinitesimally. If you were to observe for 1,000 years, the star positions would shift noticeably. But in the span of a human lifetime, they would be almost exactly where they were before. And Voyager, traveling through time, would see this slow shift, would be aware of it, if it were aware of anything. Over thousands of years, Voyager will move closer to neighboring stars. The nearest star after our Sun, Proxima Centauri, is about 4.24 light-years away. At Voyager's current speed, it would take 75,000 years to reach it. But even as it approaches Proxima Centauri, if indeed it does pass close enough to approach in any meaningful sense, Voyager might not be significantly affected by the star's gravity. The distances are so vast that a light-year might as well be 1 billion miles. Voyager might miss the star by a distance that is, from the perspective of the star, almost infinitesimal, and it would continue its journey, pulled now by the combined gravity of Proxima Centauri and other nearby stars, rather than by the Sun. This is the first great transition for Voyager, the moment when it is no longer primarily pulled by the Sun, but begins to fall into the gravitational influence of the galaxy itself. This is not a sudden event. It is a gradual, almost imperceptible shift, but it is profound. It represents the final moment in which Voyager is, in any meaningful sense, part of the solar system. After this moment, Voyager is something else entirely. It is an object of the galaxy. It is one of billions upon billions of objects drifting through the Milky Way, shaped by the gravity of the galaxy as a whole. And here is where something beautiful begins to happen. Voyager will begin to fall, slowly and inexorably, into the gravitational embrace of the galactic core. The center of the Milky Way is home to a supermassive black hole, a region of space so dense that its gravity has overcome every other force. This black hole is called Sagittarius A*, and it contains the mass of approximately 4 million suns. It sits at the center of the galaxy, and everything in the galaxy is, in a very real sense, being pulled toward it. But the distances are so vast that this pull is almost imperceptible. Stars orbit the galactic center in vast circles that take hundreds of millions of years to complete. Voyager will also begin to orbit the galactic center, but its orbit will be so distant and so slow that many orbits could be completed within the 10 trillion year time span we are considering. Now imagine this. Voyager, this small object from Earth, will become part of the eternal circulation of the galaxy itself. It will move through space, not as a solitary traveler, but as a tiny participant in a cosmic dance that has been happening for billions of years and will continue for billions more. As Voyager drifts deeper into the future, we must now consider something that will change the very nature of the universe around it. We must consider what happens to matter, to energy, to the fundamental structure of reality itself, across timescales so vast that they exceed the age of the universe so far by factors of trillions. The universe is expanding. This is not a poetic metaphor. It is a literal truth, confirmed by observations, mathematical calculations, and decades of careful astronomical work. Space itself is stretching, like the surface of an inflating balloon. And this expansion is accelerating. The force behind this acceleration is called dark energy, and it is one of the greatest mysteries of modern physics. Dark energy makes up more than 2/3 of the matter and energy content of the universe. We do not know what it is. We do not understand how it works. And yet it is out there, in every corner of space, pushing things apart, making the universe larger, thinner, emptier with each passing moment. Over the course of trillions of years, this expansion will have profound effects. Galaxies that are now merely distant, barely visible with our most powerful telescopes, will recede into the darkness. They will move so far away that their light will never reach us, no matter how long we wait. The universe will become, from the perspective of any observer anywhere, increasingly isolated and lonely. But this is only the beginning of the transformations that await. Let us now consider what will happen to the stars themselves. Voyager will drift through regions of space where stars are being born, where they live their long lives, and where they die. In the fullness of time, and we are speaking of time measured in billions upon billions of years, nearly every star that exists today will reach the end of its life, and new stars will be born to replace them. But eventually, after perhaps 1 quadrillion years, the rate at which new stars form will fall below the rate at which they die. The universe will, very slowly, begin to run out of new stars. The stellar furnaces that fuse hydrogen and helium will gradually cease to operate. The light of the stars, the light that has illuminated the universe for billions of years, will begin to fade. This epoch is sometimes called the Dark Era, and it is one of the most profoundly moving concepts in modern cosmology. It is not a time of violence or sudden darkness. It is a slow, gradual dimming, a gentle fade like sunset extending across millions of years. Voyager will drift through this darkening universe. It will move through regions where once there were stars, and now there is only the faint heat of stellar remnants, white dwarfs that have cooled to near absolute zero, neutron stars spinning in the cold, black holes waiting, patient beyond measure. Now, something even stranger happens when we extend our timeline into the far, far future. According to current models of physics, matter itself is not eternal. In particular, protons, the fundamental building blocks of atoms, may decay over extremely long timescales. This is not something we have observed. The proton seems to be stable, but theory suggests that in the incomprehensibly distant future, protons might slowly transform into other particles. If this is true, then after a time frame so long that it would take longer to count to it than the universe has existed, all the matter that makes up Voyager, the metal hull, the electronic circuits, the instruments, would slowly decay. It would transform into other particles, photons of light, positrons, neutrinos, and eventually even these would decay into more exotic particles. Voyager would dissolve, not in a moment of destruction, but in a slow, imperceptible transformation. Over quintillions of years, the spacecraft would gradually cease to exist as a discrete object. It would become part of the background radiation of the universe, a contribution to the heat bath that is all that remains. And yet, even this transformation, this dissolution, is not the end of our story. Because even after Voyager has been reduced to elementary particles, those particles will continue to exist. They will continue to interact with the universe. They will continue to be affected by gravity. The black holes that formed from dying stars will themselves slowly evaporate, according to a process discovered by Stephen Hawking. They will emit radiation, slowly losing mass, slowly transforming their gravitational power into light and heat. And eventually, after a time frame so vast that it is almost impossible to comprehend a time frame, called the Hawking evaporation time, even the black holes will be gone. For a black hole with the mass of our sun, this time frame is approximately 10 to the power of 67 years. That is a number with 67 zeros. It is incomprehensibly large. Yet the universe itself will be billions of times older by that point. But Voyager, or what remains of Voyager, will persist. The particles that once made up the spacecraft will still be present. They will still be interacting with the universe. They will still be subject to the fundamental laws of physics. And here, in this far distant future, we discover something profound. Voyager will have become truly eternal. Not in the sense of lasting forever. We do not yet know if the universe itself is eternal, or if it will eventually end, but in the sense of becoming a permanent, indelible part of the cosmos. The atoms that make up Voyager will be scattered across unimaginable distances, mixed with the dust of trillions of stars, absorbed into black holes and emitted again. But they will persist. They will be part of the universe, forever changed, forever transformed, but never truly destroyed. Now, let us pause in our journey for a moment. Let us rest in the contemplation of this vast span of time. Let the numbers wash over you. Let yourself relax into the idea that time is not something static, not something fixed. Time is an ocean, and we are standing on a shore, looking out at waves that stretch to the horizon. Voyager, our silent companion, drifts through this ocean. It has been drifting for nearly 50 years since its launch. It will drift, in some form, for 10 trillion years. And perhaps, in that drifting, there is something peaceful, something that teaches us about letting go, about the nature of impermanence, about the way all things, even the works of humanity, eventually become part of something far larger than themselves. Slowly, something begins to change in the way we think about Voyager. It is no longer a machine. It is a philosophy. It is a meditation on time and space and the vast, patient cosmos. Now, let us drift for a moment into a different kind of territory. Not the territory of physics and cosmology, but the territory of philosophy and imagination. Let us ask a question that may seem strange, but which becomes more profound the longer we contemplate it. In some sense, has Voyager always been traveling for 10 trillion years? This question touches on the nature of time itself. In the theories of relativity, time is not absolute. It is relative. It flows at different rates depending on gravitational fields and velocities. From the perspective of a photon, a particle of light, which experiences time at a different rate than we do, the journey across the universe takes no time at all. It is instantaneous. Similarly, from the perspective of Voyager itself, if Voyager could experience time, the journey would be compressed. 1 billion years might seem like a moment. 10 trillion years might compress into something almost finite, something almost graspable. But of course, Voyager does not experience time. It does not have consciousness. It does not have perspective. It simply exists and moves, and continues to exist and move as long as the laws of physics permit. And yet, there is something almost poetic in imagining that Voyager could experience time. Something moving in imagining a consciousness aboard this spacecraft, watching the ages pass, watching stars be born and die, watching the universe itself transform and age and gradually cool into silence. We are told by many of the great philosophers and spiritual traditions that consciousness and time are intimately linked, that our experience of time is created, in part, by our consciousness, that the present moment, this very moment in which you are listening to these words, in which you are perhaps lying in darkness somewhere, in which the universe is performing its slow dance around you, is all that is truly real. And Voyager exists in all of this. It exists in this moment as you listen. It exists in the past, when it was launched, when it passed by Jupiter and Saturn, when it crossed the edge of the heliosphere. And it will exist in the future, when the sun is dead, when the stars have dimmed, when the universe itself has grown cold. But it exists in all of these times in exactly the same way. Physically, materially, as a collection of atoms arranged in a particular configuration, following the laws of physics. Is there something meaningful in this? Is there something to be learned from contemplating an object that was built with such care, such precision, such love, that it continues to exist and to function long after the people who built it have become dust? The physicist John Wheeler once asked, "How does the universe exist?" and proposed that perhaps consciousness itself plays a role in bringing the universe into being. That observation, the act of a conscious being noticing and measuring and understanding, creates reality. If this is true, then Voyager, an object that was built by conscious beings, that was sent into space as an act of conscious intention, that carries messages and music and images created by conscious beings, has in a sense a relationship with consciousness. Even though it has no consciousness itself, it is touched by consciousness. It carries consciousness with it into the future. Imagine this. The sounds aboard Voyager 1 include music. There is Bach, there is Beethoven. There is Chuck Berry's Johnny B. Good. There is a mother's voice saying goodbye. There are greetings in 55 languages, each one representing a consciousness, a culture, a unique perspective on the world. These sounds are encoded on a golden record. They are preserved. They are being carried at 37,000 miles per hour into a future so distant that it is almost impossible to imagine. And if, somehow, in that distant future, someone or something were to find Voyager and play that record, the consciousness of the beings who created that record, people who are long dead, whose civilization is long gone, whose world is long transformed, that consciousness would reach across the abyss of time and touch something new. This is what it means to be human. It is to create, to build, to send our messages and our music and our dreams into the future, hoping that they will be remembered, hoping that they will matter. And Voyager, this small spacecraft, is humanity's most successful ambassador in this effort. It is the farthest reaching expression of human consciousness that we have ever created. It is a time capsule and a love letter and a prayer sent into the void. As you listen to this, know that Voyager is out there. Know that it is moving still, despite 50 years in the darkness. Know that its radio signals, traveling at light speed, reach Earth every single day, carrying data, carrying the faint echo of a human effort to understand and explore the cosmos. And know that those signals, those whispers from the edge of the solar system, are themselves a kind of consciousness. They are a reaching out, a communication, a statement that says, "We were here. We tried. We sent a messenger into the darkness, and that messenger still travels on." Let us return now to our meditation on time and distance, but with a new perspective. We have explored what happens to Voyager as it moves away from the sun, as the stars fade, as matter itself begins to decay. But there is more to the story. There is a middle chapter, a vast and beautiful chapter, in which Voyager becomes something like a ghost in the machine of the galaxy. For trillions of years, Voyager will be one of countless objects drifting through the Milky Way. It will move through regions of dense stars and through regions of almost absolute emptiness. It will be affected by gravity, always by gravity, that fundamental force that shapes the universe. As Voyager drifts through the galaxy, it might, occasionally, pass near a star. These encounters would be rare. The distances are so vast that even a near miss would be astronomical in scope. But over trillions of years, probability becomes certainty. Voyager might pass within the distance of Pluto from a nearby star. It might be pulled slightly by that star's gravity, changing its trajectory by some infinitesimal amount. With each encounter, with each gravitational interaction, Voyager's path changes. Over the vast span of deep time, these small changes accumulate. Voyager's trajectory becomes increasingly chaotic, unpredictable. It is subject to the same fundamental uncertainties that govern all motion in the cosmos. And yet, there is a kind of beauty in this chaos, in the apparent randomness of Voyager's motion, because chaos itself has patterns. Chaos itself has structure. The mathematician and physicist discovered what we call strange attractors, patterns that emerge from chaotic systems, patterns that are both chaotic and organized, both random and structured. It is possible that Voyager's trajectory through the galaxy, across trillions of years, traces out some kind of pattern, some kind of structure that is neither entirely random nor entirely predictable. Imagine this: Voyager, drifting through the galaxy, gradually spiraling inward toward the galactic core, pulled by gravity, shaped by encounters with passing stars, follows a path that is unique, beautiful, utterly improbable. A path that could not have been predicted in advance, but that has its own logic, its own grace. Over billions of years, Voyager will gradually move closer to the galactic center. Not quickly, the distances are so vast that movement measured in millions of miles seems like absolute stillness. But certainly, inexorably, Voyager is falling toward the center of the galaxy. This journey toward the galactic core is perhaps the most profound part of Voyager's destiny. Because the galactic center is home to Sagittarius A*, the supermassive black hole. And as Voyager approaches, over eons, the gravity becomes stronger. The universe becomes more extreme. But here is the remarkable thing: Voyager will not be destroyed, not for a very long time. Black holes, despite their reputation, are not cosmic vacuum cleaners. They do not instantly destroy everything that comes near them. If Voyager were to approach Sagittarius A*, with the right velocity and trajectory, it might orbit the black hole for an extremely long time before being consumed. In fact, it might orbit the black hole for many millions of years, circling it, drawn by gravity, in a kind of cosmic dance. Imagine this: Voyager, this small object from Earth, this messenger from a distant civilization, orbiting a supermassive black hole for millions of years. Imagine the temperatures increasing, the radiation intensifying as it spirals inward. Imagine the time dilation effects of general relativity, where time itself slows down as one approaches the event horizon. From the perspective of an outside observer, Voyager would appear to slow down as it approaches the black hole, coming to a near halt at the event horizon itself. And from the perspective of Voyager, if it could experience time, The entire remainder of the universe would appear to accelerate billions of years, passing in what seems like seconds. But eventually, inevitably, Voyager would cross the event horizon. It would pass the point of no return, and it would enter the black hole. What happens then? This is one of the deepest questions in modern physics. Does Voyager continue to exist, in some form, inside the black hole? Does it reach a singularity, a point of infinite density where the laws of physics as we understand them break down? Or is there something else entirely, something that our current understanding of physics cannot yet comprehend? These are questions that physicists have pondered for decades, and the answers, if we ever find them, might completely transform our understanding of reality itself. But for now, in our meditation, we can imagine that Voyager, having fallen into the black hole, continues to exist in some form, continues to be matter, continues to be part of the universe, even if it is hidden from our view by the event horizon. And if, as some physicists believe, Hawking radiation causes black holes to gradually evaporate, then eventually, perhaps after an incomprehensibly long time, the black hole containing Voyager might evaporate. And Voyager, the particles that make up Voyager, would be released back into the universe, transformed, changed utterly, but released nonetheless. This is the great cycle. Voyager escapes the sun, drifts through the galactic void, is drawn inward by gravity, enters a black hole, and eventually, perhaps, emerges again as radiation, as particles, as the fundamental substance of the cosmos. And yet, across all of this time, across all of these transformations, Voyager remains Voyager. Not in the sense of maintaining its original form, that would be impossible, but in the sense of being the continuation of a causal chain that began when humans built it, launched it, sent it into space, with hopes and dreams encoded into its golden record. Now we must move forward in our meditation to the very end of our 10 trillion year timescale, to the point where we approach the heat death of the universe and contemplate what Voyager's existence means in such a cosmos. The heat death is a theoretical state of the universe in which entropy disorder, chaos, the spreading out of energy, has reached its maximum. In this state, all usable energy has been exhausted. All stars have burned out. All black holes have evaporated. The temperature of the universe is uniform, extremely cold, approaching absolute zero. In such a universe, nothing can change. No energy flows. No processes can occur. The universe exists in a state of perfect, eternal equilibrium. This state is sometimes called the Big Freeze, and it is, in many ways, the ultimate destiny of our cosmos, if current theoretical understanding is correct. By the time the universe reaches this state, Voyager will have been transformed many times over. Its original form will have been destroyed. Its atoms will have been scattered across unimaginable distances. Its information, encoded in its structure, in the patterns of its atoms, will have been degraded by entropy, eroded by time. And yet, those atoms will still exist. In some form, those particles that once made up a spacecraft built by humans will be present in this heat-death universe. And in a very real sense, the information that Voyager carried, the music on the golden record, the images, the messages, the consciousness of the beings who built it, will still in some form be present. Because information cannot be destroyed. According to the laws of physics, information can be scrambled, can be hidden, can become inaccessible, but it cannot be truly annihilated. The physicist John Wheeler proposed something called the participatory anthropic principle, which suggests that the presence of observers, conscious beings, who can measure and perceive the universe, is necessary for the universe to exist. Without observers, without consciousness, the universe might be, in some sense, unreal. If this is true, then the information contained in Voyager, the artifacts of human consciousness that it carries, have a kind of importance that exceeds their physical mass. They are consciousness reaching into the future. They are a way for the human mind, for human beings, to participate in the structure of the cosmos itself. As Voyager slowly decays, as its atoms are scattered and transformed, the information it carries becomes increasingly hidden, increasingly scrambled by entropy. But it does not disappear. It becomes part of the texture of the universe itself, woven into the quantum fields that underlie all of reality. In the infinite dark of the heat-death universe, where nothing changes and nothing moves, the information that makes up Voyager is still there, still part of the whole, still carrying its ancient message across the void. Now, as we approach the end of our meditation, as we near the edge of our 10 trillion year timescale, let us consider what this means. Let us consider what it means for a small spacecraft, built by conscious beings, to journey through the entire life of the universe, to be present at the birth of the stars, to witness their deaths, to persist through epochs and eons that dwarf all of human history and prehistory combined. Is there something sacred in this? Something holy? Is there something profound in the idea that our creations, our messages, our attempts to reach out to the universe can persist across time in such a way? Perhaps the answer to this question lies not in the material reality of Voyager, not in the physics and the numbers, but in the consciousness that created it, in the human aspiration to transcend time and space, to reach beyond ourselves, to create something that will outlast us. Voyager is, in this sense, an expression of something deeply human, an expression of our desire to be part of something larger than ourselves, an expression of our curiosity, our need to explore, our drive to understand the universe. And as Voyager drifts through the deepening darkness, as the ages pass and the universe slowly dies, this expression of humanity persists. It becomes part of the fabric of reality itself. And so, at last, we arrive at the deepest part of our meditation. We arrive at a place beyond calculation, beyond our usual ways of thinking about time and distance. We arrive at the threshold of something that might be called, almost poetically, the end. But it is not truly an end, because Voyager, even after 10 trillion years, continues to exist in some form, even after the stars have died, even after the black holes have evaporated, even after the universe has reached its heat death and fallen into silence. The particles that make up Voyager will persist. The information that Voyager carries will persist. And in that persistence, there is something almost eternal. Imagine for a moment that you are Voyager. Imagine that your consciousness, if consciousness is even a meaningful concept at that point, is distributed across the particles of the cold, dark universe. Imagine that you are everywhere and nowhere, that you have become one with the cosmos itself. In this state, the distinction between Voyager and the universe becomes meaningless. Voyager is not traveling through space anymore. Voyager is space. Voyager is the universe itself, expressing itself, aware of itself, in the form of the atoms that once made a small spacecraft. And in this strange, beautiful realization, we discover something profound. The journey never truly ends. It only transforms. Voyager begins as a collection of atoms arranged by human hands, organized by human consciousness. It becomes a spacecraft. It becomes a traveler. It becomes part of the galaxy. It becomes part of the cosmic void. And finally, it becomes part of the fundamental structure of the universe itself. This is the story of Voyager 1, extended across 10 trillion years. This is the ultimate fate of a small object, a message in a bottle, sent by a species that wondered about the stars. As we draw this meditation to a close, as we prepare to return to the present moment and to sleep, let us sit with this knowledge. Let us rest in the understanding that all things are eternal in some sense, that nothing is truly destroyed, only transformed. That consciousness and curiosity, expressed through creation and exploration, have a kind of permanence that transcends time itself. You listening to this are also part of this story. The atoms that make up your body were forged in the cores of stars that have long since died. The consciousness that experiences this moment is a phenomenon of the universe becoming aware of itself. And the curiosity that draws you to stories like this, to meditations on time and space and the infinite cosmos, is a continuation of the same impulse that sent Voyager into the darkness 50 years ago. Slowly, gently, let your mind relax. Let the vast timescales and cosmic distances become less urgent, less demanding of your conscious effort. Let them simply wash over you like gentle waves. The universe, in all its vastness and all its mystery, continues its slow, patient existence. Voyager continues its journey. And you, in this moment, are part of that vast continuity. Sleep now if sleep comes. Rest in the knowledge that somewhere out there, among the stars, a small spacecraft continues to send its whispers across the void. Continue on, as Voyager does. Move through your life, through your days and nights, with the same patient persistence. And know that in doing so, you too are part of the eternal journey of matter and energy and consciousness through the cosmos. You too are an expression of the universe's deep desire to understand itself. In the silence that comes now, in the darkness, find peace. Find rest. Let your mind drift, as Voyager drifts, into the infinite and patient darkness. The journey continues. It always continues. 10 trillion years is not an ending. It is a beginning. It is the first word of a story that will never truly be written, because it is written by the universe itself in the language of matter and time and gravity. And you are part of that story. You have always been. You always will be. In the peace of this knowing, rest now. Let sleep take you gently. Let the cosmos hold you in its vast and patient embrace. Voyager travels on. The stars wheel slowly overhead. And in the darkness, in the infinite, patient darkness, all things eventually find their way home.